It's 101. So let's kickstart this. So welcome everyone. Thank you for joining us today. I'm Hassan Kanafer, CTO at E.C.I.Networks. A little bit about me. 25 years ago, I started as a sales engineer and moved on to a different role along the way. Network architect, product design, and ultimately as a VP of engineering. However, for the last couple of years, my mission has always been to empower our customers to adopt open networking solutions and AI technologies with confidence. Today, we are diving into how data centers are evolving to meet the demands of AI. We will explore the main innovation, partnership, and strategies making data center requirement with making this transformation both effective and ready for the future. So kicking off the discussion, I would like to introduce Mark Harris from Edgecore Networks. Mark will explain how Edgecore is leading the way in addressing today's data centers requirement with open networking solutions. Mark, over to you, please.
Thanks, Hassan. Again, my name is Mark Harris. I run global marketing for Acton Edgecore. Edgecore is a go-to-market division of Acton. Acton itself is a $3 billion networking open networking solution vendor based in Taiwan with U.S. headquarters in Sunnyvale, California. My background is I've been in networks for my entire life. I was thinking about it just recently. Almost 40 years. Almost 40 years I've been with the billion-dollar division of Digital Equipment Corporation years ago, Extreme Networks a couple of times, Cabletron, Enterasys, NetScaler, Pluribus SDN, and now Acton. So I've spent literally my entire career in the network space, both in the sales, marketing, and technology of it. I've got a deep technology background, so I always tell people network switching is in my blood, and it probably is after this many years. We're going to spend the next half an hour or so talking a little bit about the change. Again, since I've been around for 40 years, I've actually never seen this amount of change happening this short a period of time. So when I say that, it almost makes me smile because I smile because it's such an exciting time to be in the IT space. I don't know if everybody listening to this call is smiling because it means change. It means the things that you've done your entire career may be questioned. Switching, processing, software, literally everything people have grown up on and come to very good terms with over their entire career, 4 or 5 years ago changed. So we're going to talk a little bit about the AI data center challenge. AI came out of nowhere for many of us, and it actually didn't, and I'll talk a little bit more about that later. But AI data center challenge is real. It's something that everybody on this call needs to contend with and plan for and kind of leverage, because it's also a great opportunity. It's one of the things that is a career builder. So when people look back on 2024, 2025, they're going to look back at that point in their career and they're going to say, this made my career. I was the guy. I was the person that brought this kind of capability to our company. We're going to talk a little bit about the analysts. The analysts are loving this kind of change because it gives them an opportunity of really explaining to the world how they see it playing out. And luckily, there's a lot of convergence there. We'll talk a little bit about some of the open solution examples and actually some AI application examples across industries. And then we'll open it up to some QA towards the very end. So who is Edgecore Networks? Again, I mentioned before, Edgecore is the go-to-market branded version of Acton. Acton has been in the networking space for more than 35 years, made millions of switches and devices. We do a tremendous amount of private label, white box, branded, lots of joint development, ODM, lots and lots of different arrangements we have with different manufacturers. There's a very reasonable chance that the webinar you're listening to right now is somehow going through a box made by Edgecore/Acton. Our goal is pretty simple. It's really provide leadership networking technologies that are affordable and open. Years ago, I would say that really wasn't a mantra. I know the OCP and even Green Grid before that, open started becoming a topic, but our challenge and value to the industry is we've delivered it. We've gotten to the point where we can stand up with the best of any solution out there and say, why do it in a proprietary, locked-in, closed manner when you can just take the exact same requirements and apply it, use open solutions to satisfy them? Edgecore Networks is a wholly owned subsidiary of Acton Technology. We provide both AI server, the latest stuff from Intel Gaudi 3, where we were showing at OCP last week in San Jose. The AI and ML switching hardware, Tomahawk 5, for example, the Jerichos, the Ramones. Literally, we are at the leading edge of the technology you need to build data centers. The ecosystem of proven partners to help with specialized controller and AI intelligence, and literally open is our mantra. So we're one of the top contributors to the Open Compute Project. So when the Compute Project is looking for designs or really any sort of guidance, last week we put another switch into the Open Compute Project, which basically enables anybody that participates to now go off and utilize that same technology that we have millions of devices that are being used by the hyperscalers, but do it in their own world. We have 1,000 patents. As I mentioned before, our revenues are tracked in the Taiwan stock market, so you can look at it, and we're really proud of the fact that people come to us and say, how can we make this happen in an open fashion? Our innovation, again, I won't go through this heavily, but we've been the first at so many milestones throughout the industry. The devices that power telco, the devices that power data centers. We just launched the 51 terabyte switch for AL and ML with Royce and all the other technologies that the AI teams need. We've got a huge business in the enterprise switches, layer 2, layer 3. Literally, we've just been around the block. When people are looking for open, they usually find their way to Edgecore. Hassan?
Yes, thank you, Mark. So a bit more about E.C.I.Networks. E.C.I.Networks, it's a Canadian-based company with global presence, more than 25 years in business. We position ourselves as a solution integrator for open networking, but underlay we have two divisions. The first division, it's open connectivity solution, and the second division, it's open visibility solutions. So under open connectivity, this is where we assemble our own connectivity product, from transceivers to cables, including DAC and AOC cables. So data center customers use us as one-stop shop because we can program those solutions to be compatible with the big names such as Cisco, Nokia, Juniper, and more. And last year, we introduced our ready-to-plug SONiC switches. Our ready-to-plug SONiC switches, it comes with pre-tested and certified SONiC. And in addition, on top of this, it comes with our 24/7 technical support. Our second division is our open visibility product, where we design and produce our own networking tabs. That's the first layer to visibility. We also, based on our expertise with SONiC, we also built our own packet broker container on top of SONiC. That's we brand as a Packet Maestro. So Packet Maestro, it's a packet broker that provides basic and advanced visibility features, including like aggregation, load balancing, deduplication, GTP correlation, just to name a few. Next slide, please, Mark. So next slide, this one, it shows our E.C.I. value proposition. So as a first Canadian OCP member, we take strategic approach to help our customers select, source, stage, and deploy open switch solution or open networking solutions. Well, first, we do help our customers select what's the right solutions. So our systems engineering team can assist our customer selecting the right solution from an open hardware or open software perspective and make sure it's fully compliant with their technical requirement. In addition to this, we act as a single point of contact across various suppliers. We are a reseller of Edgecore, IP Infusion, Arcus, and more. So this approach gives you like access to the wide range of open networking solutions. And once your selection is done, we can help you as well to simplify your networking procurement process. So we get the white box hardware. We can also procure the NOS and make sure they are pre-installed. We also include the optics and the cables as needed. So it becomes for you, it's a hassle-free consolidated shipment, and then we can ship to different locations. Or again, with our warehousing capability in the Americas, also in Asia and the Middle East, this will help our customers further reduce the lead time. And of course, when it comes to staging and deployment, we feel that we must support you through your open networking migration journey from testing, from lab testing to POCs, and also to full deployment, full production deployment. Of course, we can provide expertise when it comes to hardware and connectivity, but also we have our automation team, engineering automation team, where they can ensure and help you to make like a seamless transitions to a production environment. So when it comes to open networking, like as you know, open networking, it's a concept that can be implemented across the entire network spectrum, like from broadband access, edge computing to mobile and core networks, and of course AI and data center and even visibility solutions. So this is where we help our customers to take the first step and to build like strategic approach to fulfill their requirement. Mark?
That's on. So I'm going to take everybody on the call through a little bit of a journey. There's, again, change is the mantra of IT today. And if you look at the first 25 years of IT, and I'm just calling the first 25 years starting when the internet was born, in and around 1995, that's 25 years ago. If you think about what was at stake there and what's happened for those last 25 years, everything associated with the power, processors, cooling, operating system, the data center designs, applications, literally, they were incremental, right? Processors got a little bigger each year. Memory got a little bigger. Data center got a little hotter. Applications got a little smarter. Power, became more critical. Literally, we dealt with this incrementally, and people moved along pretty much, from day to day, year to year. The next 25 years, and I'm saying that starts about 2020 because that's kind of when AI became part of everybody's world, right around the beginning of the COVID timeframe. ChatGPT has helped a lot of people interacted with AI, but that was really just the front end. Actually, a friend of mine works for one of the big hyperscalers, and I actually asked them, how did this happen that all of a sudden this amazing new set of technology showed up overnight? And the reality is, he said, we've been developing it for more than a decade. What needed to happen is that something had to start the infrastructure build out to run it. So they understood the technology to do AI and ChatGPT and all the other contenders that have come along since, but they didn't have that back end, because that back end looks very, very different than the back end that was currently there. The analysts themselves have said, if you look at Peter Jones, who runs the Ethernet Alliance, network boundaries are crossing the terabit per second threshold. What that means is that applications and server to server and all of the other things that are going on the back end are now crossing the terabit. We've talked about gigabit links. We've talked about 100 gigabit links. We've talked about 400 gig, 800 gig. We're now starting to say, as a standard practice, we're crossing the terabit per second to get to AI. If you look at Sama over at Deloro, AI workloads require an entirely new backend infrastructure build out. And I think that's a really powerful statement because everybody on this call should be thinking about the fact that what you have was good. And for that first 25 years, you were doing exactly what needed to be done. But your organizations, whether you're real estate, retail, biotech, farm, manufacturing, there are literally new applications that are being hatched, born, created, invented, innovated, whatever word you want to use, that are creating new ways of building the business. It's not just do what you've done for 25 years, do it faster or more of it. It's literally new ways of looking at your business to make it smarter, to make it more involved. And we're going to talk a lot about that for the rest of this 25 minutes, but also for the rest of your 25 years of computing. If you think about it, again, the first 25 years is in gray on the left side of this chart. Incrementally, life was easy, right? When you have incremental change, you're bringing more racks into the data center. You're getting the next G3 instead of the G2 rev of a server. Racks go from 2 kilowatts to 12 kilowatts to 40 kilowatts, and that was pretty common for the first 25 years. I'm just going to keep referring to it as the first 25 years. But now you're starting to see, as soon as ChatGPT and the other AI technologies hit the market, those same racks that were barely surviving and barely being cooled and barely being connected at 40K kilowatt are now being asked to be replaced by 100 kilowatt, 200 kilowatt racks, which is inconceivable for many of the people on this call and most of the people that you work with. Literally, there are racks right now that are in spec and in certain data centers that are running over 200 kilowatt racks. That changes everything about the data center. It changes everything about connectivity, power, cooling. And I like to use the word work per watt. And that sort of puts a lot of things together. How much work can you get for how much power it takes? And I'm going to talk about that in a lot of blogs and things that I write, but it's important to start thinking about how much work per watt, because it's not necessarily the space in a data center, it's how much energy you can put into a data center to do work. And you're probably seeing a theme here about energy. Everybody is talking about energy. The same discussion that we'll talk about AI is instantly talking about energy. So anybody talking about networking is also going to be talking about energy efficiency networking. Anybody talking about processors and GPUs is going to be talking about energy efficient processors and GPUs. And there's many charts that are out in the industry right now. I like this one from Thunder Energy, and it basically, and the red line, by the way, is today. It basically shows how energy demands are historically growing, but also how they perceive the growth of energy. And the reason energy is so important is because that's the leading indicator of all the devices that you're going to put in data centers. That's saying that your data center is going to change, and it's changing right about now, coincidentally. Right about now, the enterprises, everybody is looking at AI and getting past the curiosity, and they're now saying, how do I start taking advantage of that? I'm a pharmaceutical company. I'm a research organization. I have lots of constituents out there that are asking me to do more and be smarter. And so these build outs are getting past the tire kicking and proof of concepts, and they're now becoming part of the business plans. So when you look at IT, they are now saying, this is a business plan. This is going to affect me in the 2-year time frame. Next year, if I'm not doing beginnings of AI deployments, I'm probably going to be at a competitive disadvantage. Another chart that I like to use is Gartner's hype cycle. And what the hype cycle does, and you can look these up, they do 30 or so different hype cycles for different kinds of technology. It basically tracks the ideas, technology ideas, through the life cycle of great ideas, exciting, the deployment, what they call the peak of inflated expectations and trial of disillusionment in the center there. That's where you're kind of figuring out all the details. Well, how do you do it? It sounded great at first, but what are the details to make that work? It finally turns into where you start doing proof of concepts. You start figuring out how it's going to work for you, and then you're in production a couple years later. The important part here is that all of the technologies that we're talking about on this webinar, the network, AI, now AI networking, Sonic itself as an operating system, which I'll talk about in a moment, AI fabric, they're happening at breakneck speeds. Right? They are happening now. People are starting the pilots. They're starting the early proof of concepts for some of these things. And within a couple of years, you and your competitors are going to be doing it, or maybe your just competitors are going to be doing it and you're not, but you're going to be in a deficit position if you're not part of that group. So you can see that the hype cycle for networking has a lot of different technologies that are up and coming. Usually, and Gartner does a very good job of tracking what makes sense, what's really gaining momentum, what is technically elegant. And you can see that AI networking, Sonic as an operating system, really are going to become part of the vernacular over the next couple of years. And why is AI driving this data center and everything in it and around it to become new? It's really a non-traditional traffic pattern. It's something you've never seen before. It's not an incremental, what they call elephant flows are huge flows of information amongst the processors, spikes, low entropy. There's just so many different attributes that have to come through in a data center. There's a topic called job completion time, which basically, for those of you that are not deep into AI, what it basically says is you take 1,000 or 10,000 processors or 100,000 processors. At some point, a single processor can stop the other 99,000 processors because it has to complete. They all have to get to a certain point before the rest of the processors can continue. And so job completion time is one of those things that is related to the processors, the connectivity, and it's really about speed. It's how fast can you get, how much power can you power them with, and all of the things that go with it. Job completion time, packet loss. I mean, there's a lot of things that go into this. So it's not just a faster switch. I want to make sure everybody's aware. This is not just a faster switch. This is a switch that can handle the latencies and the performance that are needed by GPUs. And the topologies that you'll create, probably not that foreign. Typically super spine and leafs. This is a very common one. The switches themselves are different. The way they handle load balancing, the way they handle congestion, the way they handle performance, the links themselves. We're seeing 800 gig links, interconnect links with 1.6 right on the horizon. We're seeing top of racks that, are really feeding into deployments of GPUs and other kinds of servers, just, at the density that you've never seen before. So hopefully everybody's getting a sense for, you don't have to throw away everything you've learned your entire career, but this is happening now with or without you. And that's really, really exciting. And I mentioned Sonic a couple of times. Sonic, for those of you that are not familiar with it, it's actually the technology that Microsoft designed for Azure. So if you go look at Azure, you'll find that it's running on Sonic. They open sourced it in 2016 now. It's almost 8 years ago. They gave it to the open community, and essentially it's a layer 3. It makes everything crystal clear. It's community sponsored. I think there's over 4,000 contributors from over 500 companies now, and it's nice because you can use it off the shelf. You can use it with enhancements by vendors like us. You can use it and compile it yourself. You can do lots and lots of different things with it. But it is a simple, consistent approach to running operating systems on top of open hardware. And over time, what you'll find is that because it's hardware agnostic, a person trained on X brand white box versus Y brand white box, as long as it's running Sonic, they know how to run it. It really is very, very consistent, which helps with your operational equation. It's mature and proven. Thousands and thousands of people are keeping this thing running. It's standardized. It doesn't care the chip that's underneath it. It's open, so you don't have to worry about the lock-in or proprietary kind of features, and it's off the shelf. So you can get it in lots and lots of different ways from different vendors. It's our number one way of going to market. We believe that having a consistent operational interface into the entire stack is a good thing for large environments. And it allows the enterprises to kind of behave like the hyperscalers. That's always been one of the challenges, is that the hyperscalers, you hear about the Facebook, Metas, and the Googles, and they always sound very exciting, but a lot of Fortune 500 customers, global 1,000 customers, whatever category you're in, think of that and they say, but I'm not Google, but I'm not Facebook. How can I do the same kind of things and take advantage of the same kind of performance and leverage and pricing and all the other things? And it starts with open, and it kind of includes Sonic. So if you go down that path, open with Sonic, you're going to start looking like Google, but you're going to do it at a price level that is compatible with the typical enterprise. Computing challenges, again, on the computing side, because we talk a lot about switches, but it turns out that the compute is also really, really a big part of this equation. And we've got a whole line of products that do this. The Gaudi stuff from Intel tends to be really, really energy efficient. So as you go through and try to come up with your computing model going forward, think about both the computing and the switching, because those go hand in hand. And what happens is you start thinking about AI and AI kind of GPU computing, you think about new applications, right? You think about the operating systems to run it and the infrastructure for those operating systems, the energy profiles themselves. I mean, Intel's done a great job of saying you don't have to spend 900 watts per GPU. You can do it in half of that, right? And same kind of level. So there's a lot of things that go into this. Energy is going to be one that you want to spend a lot of time with. We have the new Intel Gaudi 3 processors. You might want to take a look at that on Google. If processing in the AI space is exciting to you, or if it's something that you care about, do a little research on the Gaudi 3 processors. Pretty leading edge stuff, and it's very energy. So it's very energy efficient. And I keep saying the word energy because I don't want anybody to leave this webinar without thinking about energy. Energy is a really, really important part of the equation. And whether you're looking at our switches or the optics or the servers, it all has to be part of the equation. And we'd love to collectively talk to you about it. And I mentioned new applications because new applications are not just the same applications that are recast. Literally, there are people that have said across all industries, I would have loved to have been able to do this level of just in time. If you're in education, enforcement, education is a great example. Right now, tens of thousands of students go to every big university, and they turn papers in every week. If you had the ability to process every one of those paper and look for things like plagiarism, wouldn't you want to do it? It's a kind of a sensitive topic, but that's the kind of new application that only makes sense, but only makes sense if you have the scale to do it. And that's what AI does. It allows you to do logistics. Amazon is doing a great job of moving products from warehouse to warehouse to warehouse to plane to warehouse to house to your home in 12 hours. It takes a tremendous amount of new application thinking to make that happen. In the financial services world, they talk about actuarial tables all the time. Because of the way things have incrementally grown up, they typically do those maybe daily, maybe weekly. But what if you could do that in real time? Because everything they do in the insurance world and financial services is about the probability of certain conditions happening. And what if you could tune your probability down to the hour? So that when you give a quote out for insurance, as an example, it's exactly what the probability would be based on the data we have up to this last hour. That's something that's very exciting. In manufacturing, supply chain, just in time, procurement, knowing that you're getting the right products at the right place at the right price. Every one of these industries, as well as most others, if they have GPUs and AI and connectivity and data centers kind of coming online that can do this, you will build a better business. And so these applications become smarter, not just more capacity. And that's a pretty exciting time to be in the IT world. So Hassan, I'll turn it back to you for the Q&A part of this discussion.
Yes, everyone, please, if you have any questions, you can input it in the QA window, and then we'll take care of it. I do have two questions, Mark. Do you know if hyperscalers or neocloud are deploying or adopting Gaudi-based systems and how it compares to NVIDIA GPUs?
Yeah, I don't have the specific numbers from Intel, but Intel was, in their words, wildly successful with the Gaudi 2. So they've got a tremendous number of installations, and it's usually customers that said either they're unable to get the NVIDIAs or they've gone even a little deeper and they've said the energy use is non-trivial. So they want to do it as a work per watt kind of thing. They want to really understand what it costs to do processing. It's not just that they can't get NVIDIA, although sometimes that's the driver. It's actually they've done the analysis to figure out they don't need to be spending the extra megawatts per month to power the same applications they have. But yeah, and Intel just introduced their Gaudi 3. Again, I don't have the exact numbers for 2, and the 3 is only recently out or coming out. So it's a successful product line, but I would not discount it or think that it's somehow secondary or second class to the NVIDIAs.
When it comes to software ecosystem, do you see any lack of Gaudi support? And do you support other NAS than Sonic? I'm assuming he's referring to the switches.
This questions about support for Gaudi processors with the switches.
No, it's a software ecosystem. Like what software are supported by Gaudi? Is it the same level as NVIDIA?
Yeah, I was just at the Open Compute for a summit here in San Jose 2 weeks ago, and every one of the tabletop discussions I was having with people was about the ecosystem that's forming. It's kind of like Android and iOS when they first started. As soon as you find a platform that's building momentum, all of the developers jump on. So there's a tremendous amount of, again, all of this is new. We're talking a handful of years before any of these topics even mattered. So it's one of the major platforms. I would say it's considered a very open platform, and so the developers are all kind of jumping on board to support Intel as well.
Another question, Mark. How about embedding AI at the data plane issue, mainly limited by P4 syntax?
We'll have to get back on that one. It's beyond my
Yeah.
knowledge.
Yeah, I think
Well,
most of the switches you mentioned are Broadcom switches, right? They are not like P4 programmable switches.
right.
Another question is, how does it compare TCO for an open networking deployment to a traditional one?
Yeah, and there's lots of, it's a great question because I talk about it all the time. If you look at TCO, which means what's the cost to operate, own, operate, really long-term kind of stuff, we use a figure of about 50% savings. So putting an open switch in with the operating system and the burden cost to operate it over a period of time and depreciation, all that kind of stuff, it's about half the price. It's enough, as well as energy efficiency. It's enough of a difference that it's worth everybody that's going down this path considering it, because it is dramatically, it's literally half the price, right? And there's lots of different studies that have, slightly different numbers here and there, but they're all kind of in that same category, that you can save about half of what it would cost you to do it with a proprietary solution by using an open solution, and it's fully supported. The fact that the hyperscalers are using it, the fact that you've got 4,000 people that are building in, if you've got a feature or function or capability that you're trying to get out of a switch and switching infrastructure, I guarantee you one of the 4,000 people have run across one of those 500 companies that they work for, and they've built it or they're working on projects to do it. So you can get very, very granular support on the solutions you need.
Maybe I can add to this, like when it comes to our visibility product, because it's based on open networking concept as well, like our TCO over 3 years versus the traditional packet broker vendor, some business case, we can go up to 60% savings over 3 years.
Yeah, the savings is one of those line items that I think it's so significant that it's fiscally irresponsible not to look at
Exactly.
using an open computing approach. 5 years ago, people were talking about open, and I would say it was more of an academic interest. But today, it's actually bet your business kind of stuff. It's real, it's production, it's mature, and it's available.
Exactly. Another question, how does open networking compare the ease of deployment to traditional solutions?
Yeah, and you can probably answer that as well as I. I think open in general makes it easier to deploy because the switches are very consistent. They're very configurable. Integrators like yourself bring together the operating system and the hardware. It can be literally turnkey deployments, and it becomes very consistent. And I want to make sure everybody does not discount the operational side of network infrastructure. By having a simple and consistent interface, it's always sonic, it always has the same command line, it always has the same set of capabilities across the same kind of boxes. It makes the ongoing management so much easier. And you probably have some experience with the deployment of large open switches as well.
Exactly. Even in our case, when it comes to our ready-to-plug switches, we pick the hardware that's required to fulfill the customer's requirements, especially from an ASIC perspective. We make sure it's compatible with Sonic. It can be community Sonic or certified Sonic, like from Edgecore. And we do the staging between the hardware and the software. We do the initial testing as well. Even for customers, we can install like initial configuration and ship it as a ready to plug to our customers.
Yeah, I think people that are on this call and people that they talk to should not hesitate of investigating it. This isn't a research project or an academic proof of excellence. This is a viable way to do commercial networking in a data center that is changing dramatically. If you go back to those charts, this is the year that big bets are being taken across the industry. Enterprises across the industry are coming up with those new applications, the actuarial tables, the just-in-time procurement. All of these things are happening now. And so those choices have to be made, right? And if you've got a brand new slate, why not make it with a choice that really matters? Right? Not just an incremental choice of what you've done for 25 years.
Definitely. Also with the new upcoming ultra Ethernet, we strongly believe Ethernet would be the way to go when it comes to AI implementations.
Yeah, true story. 25 years ago, 30 years ago, they said, twisted pair networking will never go faster than 1 megabit. And I always go back to those discussions. Maybe it was 35 years ago. And I'm thinking, well, maybe the twisted pair has changed a little bit because they were probably thinking silver satin, telephone kind of twisted pair, but it's still twisted pair, and Cat 8 now is supporting, speeds that are inconceivable. So infrastructure has changed dramatically. But open is an opportunity for everybody to kind of be part of that next 25 years of computing. And that's the beginning of it.
Exactly. I agree. Great. No more questions. Mark, thank you very much for your help. And just for everyone, this session is recorded and will be available through our social media and YouTube channel if you want to watch it again or you want to refer to colleagues. So just to wrap up, again, remember the open networking, it's a concept that can be implemented across the entire network spectrum from broadband to mobile core networks and most important to AI data centers. And if you are ready to begin your strategy, reach out to us. We can definitely help. And thank you very much for attending. Thank you, Mark, again.
Thank you very much. Have a good day.
Have a good day, everybody.